Hey everyone, welcome back to the Deep Dive. We're going to be talking about something today that honestly doesn't always get the attention it deserves, but it's a big deal, especially as we all think more and more about our impact on the planet. We're talking about embodied carbon.
Yeah,
And to help us break it down, we've got a great book to dig into today.
definitely a good one.
It's called Embodied Carbon
Mm-hmm.
by Dr. Ming Hu. She's a professor at the University of Notre Dame. And what's really cool about this book is that it's one of the first to take a deep dive into this whole idea of embodied carbon and, importantly, what it means on a global scale.
Mm-hmm.
So for our listeners out there who are all about getting to the heart of things quickly,
Yes.
this deep dive is for you.
We're going to break it down.
We're going to distill it down. We're going to make
Yeah.
this complex topic as clear as we can.
Exactly.
Today, we're going to focus on what led Dr. Hu to write this book in the first place.
Yeah, what's the story there?
What were those key experiences, those burning questions that made her decide, I need to explore this, and I need to share it with the world?
Mm-hmm.
And she starts off with a story that, on the surface, seems pretty ordinary.
Okay.
She talks about a shopping trip to Walmart.
Okay.
This was about 20 years ago, and she's just doing her regular shopping.
Right.
But something happens that really makes her stop and think.
What was that?
She comes across a product, and it's labeled Made in China.
Okay, so far so familiar, right. I feel like we see that all the time.
Exactly. But here's the thing. The price was so low, it seemed almost impossible.
Yeah, I can see how that would catch your attention.
And for Dr. Hu, it wasn't just about the price itself.
Right.
It was about what that price represented.
Okay.
It made her start thinking about the entire journey of that product
Hmm.
from start to finish.
A whole life cycle.
Yeah, like where did the raw materials come from? Who were the people who extracted them, processed them? What were the conditions they were working under? Then there's the whole manufacturing process.
Right.
And then think about the transportation, the shipping. This product traveled across oceans to get to that Walmart shelf.
It's a global journey for that little item.
It is. And as she's thinking about all of this, the comment that keeps coming back is, how can this be so cheap? How is it even possible?
Yeah, the economics of it don't quite add up when you start to factor in all of those steps.
Right. And that's what really sparked this unease in her mind. This idea that there are all these hidden costs, these environmental costs, social costs, that just aren't reflected in that price tag.
It's like the tip of the iceberg, right? What we see is just a tiny fraction of the whole story.
Exactly.
Huh.
And this wasn't just a fleeting thought for her.
Okay.
This idea stayed with her.
Yeah.
Now, fast forward about 14 years.
Okay.
And Dr. Hu is working on this massive construction project in Abu Dhabi,
Wow, what kind of project?
a super high-rise building.
Okay.
She's working with a major international architecture firm.
So high stakes, cutting edge design.
Absolutely. And this experience, it brought this whole question of globalization and sustainability into even sharper focus.
I can see how that would happen. What was it about this project specifically?
Well, here's what really stood out to her. Over 90% of the materials used to build this gigantic skyscraper were sourced from all over the world. We're talking China, Germany, the United States. It was a global sourcing effort.
So even more complex than that little item on the Walmart shelf.
Way more complex.
Yeah.
And it wasn't just the materials, even the workforce.
Yeah.
The majority of the people building this skyscraper were from India.
Wow.
So you've got this incredible mixing pot of materials and labor all coming together in one place.
It's like a microcosm of globalization in action.
It is. And here's where it gets really interesting. Despite this incredibly complicated global supply chain, all the transportation involved, all the logistics of getting everything and everyone to Abu Dhabi, the construction costs were shockingly low.
That's a head scratcher. How could it be so inexpensive with all of that going on?
Right. And that's precisely the question that Dr. Hu started grappling with. It made her wonder, could it be that globalization itself, the system we've built, is inherently reliant on some degree of resource exploitation?
Because someone, somewhere, is paying the price, right? Whether it's in terms of environmental impact or labor conditions.
Exactly. And here's another layer to this. Despite this massive global footprint, the project actually achieved LEED Gold certification.
Really? That's pretty impressive.
It is. LEED, that's Leadership in Energy and Environmental Design, is a well-respected standard for sustainable building.
Right.
But for Dr. Hu, this raised a critical question. Can a project with such far-reaching material sourcing truly be considered sustainable?
It makes you question what we really mean by sustainable, doesn't
It
it?
really does. Is it enough to just focus on the building's operational efficiency, how much
Yeah.
energy it uses once it's built? Or do we need to consider the entire life cycle of the building, from the sourcing of the materials to the end of its life?
The whole picture.
Exactly. And this is where embodied carbon comes in.
Okay.
Dr. Hu points out that while the building industry has made progress in reducing operational energy,
Yeah.
embodied carbon, the emissions associated with all those upstream processes, it's been largely overlooked.
And what are the consequences of that oversight? I mean, why does it matter if we're not paying attention to embodied carbon?
Well, she argues that ignoring embodied carbon can actually make environmental injustices worse,
Okay.
and it can disproportionately impact vulnerable communities around the world.
How so?
She gives this really powerful example. Imagine raw materials being extracted in one part of the world, let's say Africa. Then those materials are shipped to China for manufacturing, and finally they're sold as finished products in the United States.
So we're talking about the whole global supply chain again.
Exactly. Now, all those emissions associated with every stage, the extraction, the transportation, the manufacturing, it's all embodied in that final product.
Right.
But here's the thing. Those impacts, they're often felt most acutely in the places where those raw materials are extracted and where the manufacturing happens.
Places that often have fewer resources to deal with those impacts.
Exactly. They might not have the same environmental regulations or the same capacity to adapt.
So we're essentially externalizing the environmental burden.
In a way, yes. And that's why Dr. Hu is so passionate about bringing embodied carbon to the forefront. For her, this book is about championing a more holistic approach to sustainability, one that recognizes these interconnected impacts and prioritizes resource efficiency and responsibility throughout the entire life cycle of everything we build and consume.
It's about understanding the true cost of things, right? Not just the price tag we see at the store.
Absolutely. And to really understand embodied carbon, Dr. Heel starts by making a really important distinction.
Okay.
She differentiates between embodied energy and embodied carbon.
I feel like those terms get used interchangeably sometimes, but there's a nuance there, right?
There is. It's a crucial difference. Embodied energy that refers to all the energy consumed throughout a product's entire life cycle.
Okay.
But embodied carbon that specifically focuses on the greenhouse gas emissions associated with all those energy inputs.
So it's about the climate impact specifically.
Exactly. And here's the key. You can have the same amount of embodied energy, but end up with different levels of embodied carbon.
How does that work?
It all comes down to the source of the energy.
Okay, that makes sense. Different energy sources have different carbon footprints.
Precisely. To illustrate this, she looks at electricity generation in the United States in 2021.
Okay.
Now, generating 1 million BTUs, that's British thermal units, of energy from natural gas.
Yeah.
That produced about 53 kilograms of carbon dioxide equivalent emissions.
Okay.
But if you generate that same amount of energy from coal, you're looking at almost 96 kilograms of CO2e emissions.
So more than double the emissions for the same amount of energy.
Yeah. And that really highlights how the fuel source makes a huge difference.
It's not just about how much energy we use, but where that energy is coming from.
Exactly. And to make this even more concrete, Dr. Hu brings in data from the EGRID database for 2022.
Okay.
Now, in the New York City, Westchester area, natural gas that made up over 90% of their electricity generation fuel mix.
Okay.
But over in the SRC Midwest region, it's a different story. Coal was over 2/3 of their mix, with natural gas being a much smaller part.
Wow. So a big difference in the energy mix depending on where you are.
Huge difference.
Yeah.
And what that means is, if you're generating, let's say, 1 kilowatt hour of electricity in the Midwest,
Yeah.
you're producing almost twice as much CO2e emissions compared to generating that same kilowatt hour in New York City.
About 1.89 times greater, right?
Wait, that's it. And that really brings home how the regional energy grid, how reliant they are on different fuels, that has a significant impact on the carbon footprint of something as basic as electricity.
It's a good reminder that even if we're doing everything we can to be energy efficient in our own homes, the bigger picture matters too.
It does. And that bigger picture, it has a history.
Okay.
Dr. Hu takes us back to some of the early thinkers who laid the groundwork for all of this research on embodied energy and carbon.
Kind of the pioneers of this idea.
Exactly. And she starts with Frederick Soddy.
No, I'm not familiar with him.
Okay, well, he was this fascinating figure back in the early 20th century.
Okay.
He was a chemist by training, But he got really interested in economics,
Yeah.
environmental issues.
Interesting combination.
It was. And his work was very interdisciplinary. He was looking at the flow of energy through the economy.
So kind of ahead of his time in a way.
Very much so.
Yeah.
And Doctor Who speculates that maybe his ideas didn't catch on right away because they were so new and they spanned so many different fields.
It can be hard to get people from different disciplines to really talk to each other, even today.
It can. And back then, you also have to remember the world was a different place.
Yeah,
Sustainability wasn't really the buzzword it is today.
right.
The focus was much more on industrial growth, economic expansion.
And dominant economic theories like neoclassical economics, they weren't really built to account for things like finite resources or ecological limits.
Exactly. But Saudi's work, along with later contributions from people like Wassily Leontief, who developed input-output analysis.
That's a way to map out all the connections between different industries, right?
It is. And then there's Nicholas Georgescu-Roegen. He really emphasized the ecological constraints on economic activity.
Okay.
And, of course, Herman Daly, who built on those ideas and advocated for a steady-state economy.
So all these thinkers were challenging the status quo in their own ways.
They were. And Dr. Who makes the point that they were essential in paving the way for the more focused research on embodied energy and carbon that emerged in the 1970s. And it was in the U.S. in 1973 that the term embodied carbon really started to take shape.
A pivotal moment.
It was. This was with a groundbreaking report by Dr. Robert A. Herendeen.
Okay.
The report was called The Energy Cost of Goods and Services.
So getting to the heart of the matter.
Yeah. And this report, it laid out a model for actually quantifying the energy used throughout the entire life cycle of consumer goods and services.
So not just the energy used to, say, run a washing machine, but all the energy that went into making that washing machine in the first place.
Exactly. And it was funded by the National Science Foundation and developed while Dr. Herendeen was at Oak Ridge National Laboratory and the University of Illinois.
So serious research going on here.
Oh, absolutely. And the level of detail in this report is amazing. He used this massive data set from the U.S. Department of Commerce, the 1963 Input-Output Financial Data Table.
Okay.
And he used it to establish these embodied energy coefficients for a mind-blowing 362 different economic sectors.
That's incredible. So they were really trying to paint a comprehensive picture of the energy flows in the economy.
They were. And Dr. Herendeen, he even went so far as to provide a very precise definition of total energy cost.
Okay.
And that included all the energy inputs involved in the entire chain, from extracting the raw materials to processing, transportation, manufacturing, even marketing.
So cradle to grave, basically.
Exactly. And this was really foundational work for understanding the environmental impacts of everything we do. And specifically, it laid the groundwork for understanding embodied carbon in the built environment. And then building on that, in 1976, the U.S. got its first handbook for actually calculating embodied energy.
Okay.
This was Net Energy Analysis, Handbook for Combining Process and Input-Output Analysis.
Quite a mouthful.
It is. And the author was Clark Bullard, who was actually a colleague of Dr. Herendeen.
So the research was really gaining momentum.
It was. And this handbook, which was funded by the Energy Research and Development Administration, laid out the methods for calculating both the direct energy inputs, the energy used directly in the production process, and critically, the indirect energy inputs.
And those are the upstream energy inputs we were talking about earlier.
Exactly. And one of the key insights from this early research was that for the average consumer, the indirect energy associated with all the goods and services they buy, it often exceeded the energy they directly consumed.
Interesting. So it's not just about the energy we use in our homes or for transportation. It's about all the energy embedded in the stuff we buy.
Precisely.
Yeah.
And the researchers, they define this indirect energy very specifically. They said it's the energy consumed indirectly as energy used elsewhere in the economy to produce the other goods and services purchased by consumers.
Okay.
And Dr. Hu points out that this is basically the same definition that's now widely used for embodied energy.
So the terminology has evolved, but the underlying concept has been around for a while.
It has. And to make this even more interesting, Dr. Hu shares an anecdote from an interview with Dr. Bullard.
Okay.
And Dr. Bullard talked about how he initially got involved in this whole idea of quantifying embodied energy and carbon. He was looking at how different lifestyles, particularly different spending patterns, could impact the overall energy demand in the economy.
Like how much people were spending on gasoline, for example.
Yeah, things like that. He was interested in how those differences between wealthier and poorer households could ripple through the system.
So it's not just about individual choices, but about the broader economic structures that influence those choices.
Right. And that led to this crucial realization that businesses, no matter what sector they're in, they need this information about these indirect energy effects.
Yeah. If you're a company trying to make more sustainable choices, you need to understand the full picture.
Exactly. And she gives this example of car manufacturers.
Okay.
They might be considering using aluminum instead of steel to make their cars lighter.
To improve fuel efficiency.
Yeah. But then they have to recognize that the production of aluminum, that's way more energy intensive than steel production.
So there's a trade-off there.
There is. And Dr. Bullard actually said that there was a real market demand for this kind of research, which shows how practical this knowledge is. It's not just an academic exercise.
It's about making informed decisions in the real world.
Absolutely. And Dr. Hugh doesn't just focus on the U.S.
Okay.
She gives us a snapshot of the global interest in embodied carbon. And as of March 2024, peer-reviewed publications on this topic, they span an impressive 72 countries.
Wow.
It's pretty amazing. And in terms of regions, Europe and Asia are leading the way, with 27 and 30 countries contributing, respectively.
Okay.
And then you've got South America with 3, North America with 3, Oceania with 2, and Africa with 7.
So it's a global issue, but the research efforts are still somewhat concentrated.
Yeah. Most countries,
Right.
actually about 87.5% of them, they've only produced 10 or fewer publications.
Right.
But then there's this smaller group, about 12.5%, that have really been leading the charge.
Who are the big players?
Well, the UK comes in at number 1 with 63 publications.
Right.
And then you've got China with 59, the US with 53, Australia with 49, and then Italy, Malaysia, India, Scotland, and Belgium all have over 10 publications.
So it's a mix of developed and developing countries.
It is. And what's interesting is that Dr. Hu points out some key differences between the global south and the global north when it comes to how they're approaching embodied carbon.
Makes sense. Different parts of the world have different priorities and challenges.
Exactly. So in the global south, which is typically developing countries, they're really focused on developing robust methods and procedures for inventorying, measuring, and predicting energy use. And importantly, they're trying to anticipate how much embodied carbon will increase as they continue to develop.
So they're trying to get ahead of the problem.
They are. With so much new construction happening in those regions, there's this real need for reliable data and tools to inform planning and mitigation strategies.
Build it right from the start.
Exactly. Now, in the global north, which is generally the more developed countries, the focus is a bit different.
Okay.
They're dealing with a lot of existing buildings that need to be retrofitted and made more energy efficient.
Like in the European Union, I think Dr. Hugh mentions that something like 75% of buildings were built before 1990.
Yeah, there's a lot of older infrastructure that needs attention.
Mm-hmm.
So for them, the priority is on developing really precise methods for measuring the embodied energy and carbon in those existing structures,
Okay.
and also in the materials they're using for renovations.
So understanding what's already there and making better choices for upgrades.
Exactly. And this is all crucial for informing climate change mitigation efforts in countries with established infrastructure.
It's a different set of challenges.
It is. And to wrap up the introduction of her book, Dr. Hugh reflects on this whole journey of embodied carbon, from those early scientific inquiries to now, where it's recognized as a key part of tackling climate change.
It's come a long way.
It has. And she gives credit to those early visionaries we talked about, like Sadi, George Kurosian, and Daly.
For laying the foundation.
Yeah. And while embodied carbon has gone through phases of being in the spotlight and then fading to the background, Dr. Hugh emphasizes that its importance is now firmly established. It's not going away.
It's part of the conversation now.
It is. So with that, we've come to the end of our initial deep dive into embodied carbon.
And hopefully our listeners now have a better grasp of what drove Dr. Hugh to write this book.
Yeah. We've explored those key experiences that shaped her thinking, from those hidden costs in global supply chains to the complexities of defining what sustainable really means. And ultimately, it's about the urgent need to address this often overlooked aspect of environmental impact. She goes into the challenges of measurement, the impact of our material choices, the policy initiatives that are being developed around the world, even some really innovative low-tech solutions.
So it's a call to action in a way.
It is. It's about recognizing that The choices we make, both individually and collectively, they have a real impact.
It makes you think about all the stuff we interact with every day, all the buildings around us, and the hidden carbon footprint that comes with them.
It does. So we encourage you to check out Embodied Carbon by Dr. Ming Hu if you want to dig deeper into this essential topic.
It's a fascinating read.
Thanks for joining us for this deep dive. We'll be back soon with another exploration.